Hi everyone, I hope you're having a wonderful afternoon so far. My name is Alyssa, and for today's super cool experiment, we are going to make fireworks in the house. Totally safe and super fun and awesome experiment to try. So before we jump into the experiment, I'm going to do some background information on the science behind how we're going to make fireworks, and then we're going to jump right into our experiment. All right, are we excited? We ready? Let's go. So for our experiment, fireworks in a jar, we're going to learn more about liquid densities, and then we're also going to kind of talk a little bit about mass, volume, and polarity as well, and kind of go through and see how oil and water aren't going to mix together, which is the sole base of our experiment. But before we jump into our experiment, let's go over the background information and definitions we need. Some words we're definitely going to need to know for this experiment include density, which is a word used to describe how much space an object or substance takes up, its volume, in relation to the amount of matter in an object or substance, its mass. Mass is a measurement of the amount of matter in an object or a substance. Volume is how much space an object or substance takes up. And polarity is a molecule that is positively charged at one end and negatively charged at the other. Going into density a little further, you need to know that density equals mass divided by volume. Now, this equation is used throughout almost every science platform we'll come across. The nice thing about mass when it comes to this equation is that it's a universal measurement. It's used all over the world. And the other nice thing about it is that it doesn't change due to changes in gravity, such as weight. So if we were doing an experiment and taking different measurements of our weight on Earth compared to our weight on the moon, we would come to find out that we weigh more on Earth than we do the moon, but our mass would stay the same on each location. And that's why a lot of scientists end up using mass, because it's universal and it doesn't change due to gravity. Mass is measured in grams and kilograms. Volume is usually measured in cubic meters. This is usually expressed in liters or milliliters. The other thing about volume, breaking it down a little further, say we were looking at our living room and we were looking over our, say, couch and then a toy dollhouse. Comparing those volumes, we're going to find out that the couch has more volume than the dollhouse because it's going to take up more space. The larger an item is, more space it takes up, the larger volume it has. And going more into density, if an object is heavy and compact, it's going to have a higher density. And if an object is light and takes up a lot of space, it's going to have a lower density. Now, going more into the density of oil and water, which our experiment is based off of this assumption and this, as we'll come to find out, concrete evidence, we will find out that oil and water won't mix together due to their varying densities. Oil is a lot less dense, which causes it to float on top of the water. Now, you're probably asking, why is this the case? How do we know that oil and water have such different densities? One of the reasons we know this is because both of their molecules are packed differently. So water molecules are packed very densely, and since there are more water molecules compared to oil, with that, it's going to cause the water molecules to sink under the oil. And also looking at polarity, we come to find out that water is a polar molecule, and the unique thing about polar molecules is that they only dissolve with polar solvents. The same is also true with non-polar molecules. Non-polar molecules only dissolve in non-polar solvents. So if we look at oil, it has a shell of negative charges or electrons surrounding the molecule, which causes it to become non-polar, and non-polar molecules, so the oil is going to stick with oil molecules, and the water molecules are going to stick to water molecules because water's polar and oil is nonpolar, so they're not going to mix together, which explains why they eventually separate into two distinct layers. Even if we were to take a spoon and mix the oil and the water together, over time we're going to see that separation between the water and the oil, which is how our experiment is going to come to be. Talking about our experiment now, let's go over the materials we're going to need to get started. You're going to need an empty jar. I'm going to end up using a mason jar of glass. You're going to need 4 tablespoons of cooking oil. I'm going to use the vegetable oil I have in my kitchen. It didn't specifically say that one cooking oil is better than the other, so double check with mom and dad on what kind of cooking oil you have, and it should be perfectly fine for this experiment. You're going to need food coloring, water, a bowl, some paper towels, and a spoon. Now, once we have gathered all those materials, let's jump over to the next part of our video where we do this step by step and we create our fireworks display. All right, you ready, guys? Let's go. All right, guys, so we are now ready to start our experiment. We have our background information on density, a little bit more information about oil and water and how they don't mix. Now we're going to see it in action. All right, so I have gathered all my materials in my kitchen here. Make sure you double check with mom and dad that it's okay to do the experiment and have them jump along and join you and have them watch the fireworks show too. All right, so I have already filled my glass jar. I'm just using a traditional mason jar. 3/4 of water. I am now going to measure out 4 tablespoons of vegetable oil, which is just oil I had in the kitchen. I am going to put my bowl on the piece of paper towel so I don't make a mess, and then I'm going to carefully pour vegetable oil into my measuring spoons. Again, double check with mom and dad if you need help for them to pour the oil into the bowl. Totally fine. All right, so I'm just going to quickly measure this all out. 1, 2, 3, and 4. Awesome. All right, I'm going to quickly just put that on the table, move my vegetable oil out of the way. And for the food coloring, you can use whatever colors you want. I'm going to end up using all 4 because I just want to see all the colors work. So when we are adding food coloring into our oil, we're going to put about 3 to 5 drops. So I'm probably going to do 4 drops of each color. Again, you can use just blue and red if you want to do all 4 colors, or if you have some really cool like pink and purples, I say absolutely go for it. So you're going to add this into your oil first. So food coloring into oil. 1, 2, 3, 4. All right, so that's the green. Now I'm going to take my blue. 1, 2, 3, 4. Red. 2, 3, 4. Ooh, that one had a 5th extra one added in. All right. Now we're going to add yellow. 1, 2, 3, 4. Awesome. All right. So once you've added all your food coloring, however many colors you want, or if you want to stick with one, absolutely fine. You're then going to take your spoon and you are going to mix your oil and your food coloring together. Now, you're going to notice that it's not really mixing together, and that's totally fine. The mixing of the food coloring and the oil is just to essentially break up the food coloring particles. So they're a little bit smaller than just giant blobs. And then once you feel fit of your mixing, You're going to carefully pull your spoon out, put it on the paper towel, and then when you are ready, you're going to rebring your glass of water over to the screen, and you are going to carefully pour your mixture of food coloring and oil into the bowl. And then, once we do that, we just sit and wait. And as we start noticing the food coloring, so I had one start going. So as the food coloring starts processing with the oil and the water, we're going to start slowly seeing the food coloring kind of mix down and shoot into the water, causing it to look just like a fireworks display. Now, I know it's really hard to see on my computer screen the effects of it, but mine's slowly getting there. I'm slowly starting to see the colors come down, which is totally fine. You might have to be patient and give it a couple minutes for it to really start getting the great effects. Oh, that's a multicolor one. So sit and watch. Enjoy your fireworks show. Oh yeah, look at it all come down right now. Whew. That is incredible. How cool is that? You can have fireworks year round. We don't even have to wait for July anymore. All right. So, from our background information, you're probably curious as to how this experiment is working. Well, the basis of this experiment is that the food coloring will mix with water, but not with the oil. So the food coloring is actually water-based. Oil and water won't mix at all just because of the difference of densities with them. And because the oil is less dense, you're going to see that it floats more towards the top. And the food coloring is going to, because the food coloring is more dense than the oil, it's going to shoot down into the water and mix with the water, which is how we get our fireworks display. Really super cool, huh? Who knew that making fireworks is science and fun all together in one? Now, you can do this experiment as much as you want. Again, double check with mom and dad before you start going through all the cooking oil in the house. But I'd love to hear your results. Did you have a super cool fireworks display? Is yours kind of doing what mine's doing right now, where all the colors are mixing together and it's turning into a black firework display? So maybe you have to try with just one or two colors to see the full effects. Maybe you only want to use one. But definitely let me know if you got the experiment to work and if you thought the results were just as cool as I did. Well, enjoy the rest of your day, guys, and I'll see you soon. Bye!